Hello, everyone. I'm Fengqi. My background is focused on architecture, design, urban planning, and now I'm focused on the data management and the software development at Oak Ridge National Lab. So it's very honored to be here to allow me to share our group's research and design works focused on the community spatial data visualization and analytics, and we call it urban energy scoping, escaping. So let me first give some background of this presentation. Like today we have already seen the increased renewable energy integration technology developed at the different level, like building level, community level, urban level. And we also see many new socio-spatial issues related to local energy production in urban development process. And a much greater level of renewable energy will be planned at the system level. So this will require like architect, urban planner, engineers, as well as the stakeholders to have a more collaborative approach to resolve the renewable energy integration issues for the building environment. So theoretically, in the future, if we consider a building works like a tree, right, like can metabolize the energy by itself, the fundamental question here is, what does a forest look like? In other words, as much great level of renewable energy resource will be planned for the future and integrated into the building environment, and the great modeling efforts designed to increase the energy efficiency of buildings, communities, how can this change affect the city development is a primary question for us. So to answer the previous question, one important feature we identified is as infrastructure system will need to handle great distributed renewable energy resource, a new planning framework and tools will be developed to guide those different stakeholders and even homeowners about how to plan, design their building and community from a system development perspective. So in this case, we establish a foundation to connect the urban planning and the grid planning as a whole co-planning process. In general, like with the data and software foundation, which we will be introduced later, it will help different decision makers to have like the building specific energy performance analysis, this kind of frameworks, if involved in a community development process. So let me put some like specific use case here. Like in a typical community planning and development process, like the community and urban area with specific interest will be defined as this diagram shows. So different factors such as transportation, buildings, like the socio-economical constraints will be taken into account to understand the geographical and the geospatial context of the selected region. So for example, like planning features such as the land use types, floor area ratio, this kind of street, transportation, buildings will be developed as different layers to help knowing more about the community characteristics. So after like getting basic information about the community, city planners would always like to do this kind of scenario-based analysis. For example, how this community would be developed based on future weather scenario. What would be the possible way to dealing with this future energy initiatives applied to the different community. So, for example, if the energy justice and the equity dimensions has been defined for the specific analysis, like we will need a different data and the design interface to understand the issues related to the community as this diagram shows. Or like if the issues is related to any burden, a building specific energy evaluation layer will be developed to downscale the problem from community level to individual building level. So this is what we do here. Like in this case, In our team, we're trying to develop this data layer to show in the specific building energy information, such as building consumption patterns, energy cost related to each of the building, and add these layers to the original workflow. And this will have significant impact regarding like formulating public engagement plan, energy policies in terms of electrification and the decarbonization for specific community. So in general, when the energy perspective comes into the community design and urban development process, the urban planning process is increasingly focused on sustainability, aim to integrated green space, promote energy efficient building, and reduce the emission. However, the development of the community and urban system cannot stand by itself without the power grid, especially under the context of electrification and decarbonization. So, for example, as building become an important part of infrastructure system, new residential, commercial, or industrial development increase the electricity demand in certain area. So to manage this growth in demand, we need to plan the grid carefully. For example, working with the urban planner is essential to, like, grid planner need to work with the urban planner, and this is essential to align with development with the grid capability improvement. So in this case, like, cooperative planning ensures these sustainability initiatives are both technically and economically feasible. Let me just put some specific examples to understand this concept of co-planning. As we know, like, many communities are, like, advocating the increased EV adoptions to reduce carbon emissions. However, the grid capability is currently constrained in certain area, like for example, disadvantaged community. So limited support for additional EVs. So in this case, the urban planning must collaborate with the power grid planners to ensure the infrastructure that can handle the increased load from the EVs, avoid the potential blackout, and ensure the reliable EV charging options. So when the integrated grid and urban planning frameworks, it will enhance all the points like this in this slides. For example, it will increase the community reliability and building efficiency within specific community, or it will reduce the cost and maintain the, like the conflict, minimize the conflict between the urban development and the grid development. So in this case, coordinating these efforts into the grid and the urban planning can ensure the electricity infrastructure development align with the long-term goal and needs of urban population, optimize the efficiency, reliability, and the resiliency of the community or cities. So for the next few slides, I would just let Shovan to show how does our team leverage over like data and software capability to dealing with the specific issues I just mentioned regarding this urban and grid co-planning. Yeah.
Thank you, Frank. So my name is Shovan. So I also work at Oak Ridge National Lab. At Oak Ridge National Lab, we actually developed a software suite called AutoBEM, and it is a software suite which is capable of simulating building energy for millions of buildings at the same time. It actually takes several buildings characteristics data as an input, for an example, building footprint, height, type, etc. And it develops a building energy model using OpenStudio and simulate using Energy Studio at the supercomputer environment. So to be more specific, AutoBEM software suite has the capability of simulating 1 million buildings per hour, and it is licensable from Oak Ridge National Lab. you can see that the AutoBEM software actually takes certain building characteristics data as an input. So the question is that where do this building data come from? Here comes the Model America. So at Oak Ridge National Lab, we developed a database, building database, which we call Model America. It has 125 million buildings in version 1, from which we already simulated 125 million buildings, and we already shared publicly 122 million buildings models and simulation results, also with the building information data. So it is publicly available, version 1. For the version 2, we have more building, and it's already in process. We will be make it publicly available very soon. So leveraging this AutoBEM software suite and Model America database, we actually developed several applications with several stakeholders. So at the building level, city level, or like state or national level. So I will share some of the application of our team. So this one is a building level application. In this application, we created a universal design space. You can select any kind of building type. You can select the area, you can see, and also like certain HVAC properties and all other information of the buildings, and then you just create a graphical visualization scenario so that you can find out these types of graph, like energy use intensity versus total area. You can just change all of these characteristics. Also, you can see the regression analysis for each of the building features to the energy use intensity, and you can also find the sensitivity analysis for the energy use intensity. Another building level application is the capability of ground source heat pump integration. So we actually developed a interface which you can use for the assessing the capability of ground source heat pump integration. Like if you want to install ground source heat pump for your building, you can see how much energy you can save yearly, and how much cost you can save yearly, and how much the payback period for your investment. You can see this is the interface. You can just click any address in the US, it will find that building, and you can just give some of the building information, you see, building type, height, and you also can like change the building footprint. Like if you think your footprint is not matching, you can actually change it here in the interface, and then you simulate, you get the results. So you can see the annual in the left side, there is an annual energy savings, natural gas savings, and you just set the price of electricity, natural gas price, and you will get all of this information. If you see the right side, so you can see for specific selected buildings, you will get all of your investment back. Payback period is 7.2 years. So this in this interface development, we used AutoBEM and Model America database. So this is a city level application. We worked with Electric Power Board of Chattanooga to create a digital twin of 178K buildings in its service territory. And we create a visualization platform. You see, this is a visualization platform. And if you click any of those buildings, and you can see right side, for that specific building, how much energy you can save if you like choose any kind of a specific HVAC settings or like a specific measure implementation. For an example, you can see the first one. If you insulate the roof of your building, you can save certain percentage of savings per year. So another thing we did, we actually created the future weather files for all over the US counties. So for the building energy simulations, we need a weather file to simulate the buildings because the buildings in Nashville will not have the same energy consumption as in Miami, right? So the weather files actually differs the energy consumption scenario. So, and Intergovernmental Panel of Climate Change, they actually defined five socio-economic pathway, and also IPCC created a representative concentration pathway to set pathways for greenhouse gas concentration. So we actually developed future weather files for the building energy simulation for 4 SSP RCP scenarios, and we developed for 120 years time frame, like 1918 to 2100 years, within 20 years time period, and we developed it for 3,128 country, almost every US county, and 18 representative cities for each climate zone. We use 6 climate models to generate these fTMY weather files. So if you want to know what will be the energy consumption will be in the future, like in 2050 or 2080, you want to see the energy consumption of your buildings, we are capable of doing that. And we actually did exactly the same thing when we did a collaborated project with Southwest Urban Corridor Integrated Field Laboratory. It's a DOE project. It's a state level application. So we created we actually simulated all buildings in Arizona, like 2.5 million buildings from Arizona. And then we integrated all of these future weather files, and you can see in the right side, if you select any of those buildings in the visualization, it will show you how much energy consumption will increase or decrease in future, and how much electricity consumption will increase, or like how much natural gas consumption will increase or decrease. So these are the capabilities of AutoBEM and Model America, and we can see that in future most of the buildings energy is like going to be increased energy consumption. So that's what our future research is. We can actually try several other HVAC settings and measure to implement, like find out what we can do to reduce energy consumption. Yeah, so that's what we can do with the AutoBEM and Model America. If you want to learn more about this AutoBEM and Model America, we have some flyer for you. Just talk to us. We will share with you. And I will take over the conversation again to Frank again.
Okay. Okay, thank you, Shovan, for the introduction of the project. Yeah, so with this kind of introduce the software and data capability, so for develop more resilient, urban environment while considering larger amount of renewable energy in the community, like integrating the data capabilities such as AutoBEM and the Model American into the urban and the grid co-planning framework would inform the solution, policies, and urban development suggestions at different scale, as this slide shows. So for the future development of renewable energy technology at the community level, we are proposing this contact-based community and urban development platform to, to dealing with the complex socio-spatial issues coming from the building environment, and use this platform to inform actionable model-based dialogue among different stakeholders, architect, contract, urban planners from different perspectives. And this effort is trying to accelerate the decarbonization and the electrification of buildings and the grid ecosystem. At the end of this presentation, I would like to thank everyone who has contributed to this project, and especially thank to the different office of Department of Energy for their invaluable support. Yeah, just want to know if there's any questions. Okay, thank you.